So welcome. So this is a continuation of our first lesson. In the first lesson, we looked at an example of a displacement reaction, and in that reaction, we were able to see establish the oxidation and reduction in terms of transfer of electrons. So right now, I want us to look at the oxidation number. So oxidation number, so this is the apparent charge that an element has in a compound or charge on an ion. So it is important for us to always be able to know the oxidation number, because first, using the oxidation number, it is possible for us to trace the movement of the electrons in the redox reaction. And secondly, it is also important in understanding how some of the inorganic compounds are named. For instance, we have a substance like which have a valency of more than 1 and 2. More than 1, I mean. So like for instance, we have copper. So we can have copper 1 oxide, copper 2 oxide. So that 1 and that 2. So in copper 1 it means that copper lost 1 electron. In copper 2, 2 electrons, and so on. It is therefore important for us, to know some of the rules that are used in the assigning the oxidation number. The first rule says oxidation number of an combined element is always 0. If you're given any compound and it has no charge, it is not an ion, it is not a radical, then the oxidation number of that element or compound is 0. Example, like if you're given something like sodium, that's an atom, because it has no charge, then the oxidation here is 0. The oxidation number is 0. Same case if we had a compound, maybe we have sodium oxide, the oxidation number is 0 because that's not a radical and that's not an ion. Rule number 2, the charge on an ion containing one element is equal to the oxidation number of the element. If you have an ion, a good example, I'm going to use a good example. We can have an ion of sodium. So this is sodium ion. So the oxidation number of that ion is, or sodium ion, therefore is +1. I want you to note the difference of writing the oxidation number and the charge. So for the oxidation number, we always begin with the sign followed by the number of electrons either gained or lost. Like in this case, because the sign is plus, then it means that sodium loses. And how many electrons does it lose? 1. Another example, you can have chlorine ion. So the oxidation number of this one is -1. Let me give you an example of where the oxidation number is not 1. We can have something like magnesium ion. As you can see, this is how we write the charge. We start with the number followed by the sign, but when we come to writing the oxidation number, we start with the sign followed by the number. Same case if it was an ion, like we can have oxygen ion. So the oxidation number in that case is -2. So the charge on an ion containing just one element. So that's to help us distinguish one element, not a radical. One element is equal to the oxidation number of the element. The third rule, oxidation number of hydrogen in all compounds that contain it is +1, except in metal hydrides where it is -1. I'm going to give you an example here. So we know hydrogen is in group 1. It tends to form the positive ion. So it tends to have that, while the oxidation number is +1. Like for instance, in water, H2O, the oxidation number of hydrogen is 1. But in metal hydrides, the oxidation number is -1. A good example is we have the sodium hydride, we can have the magnesium hydride, and so on. So the oxidation number of hydrogen in this case is -1, and in this case, actually it should be MgH2, it's also -1. So the fourth rule. So the fourth rule, the oxidation number of oxygen in all compounds that contain it is always -2. Note that, except in peroxides where it is -1, and also in oxide fluoride where it has an oxidation number of +2. So all compounds that have oxygen, then the oxidation number of that oxygen is always -2. The only exceptions are when we have peroxides. A good example, we can have hydrogen peroxide. Another one, we can also have sodium peroxide. So in this case, the oxygen in these peroxides have an oxidation number of -1. And of course, in our third exception for oxygen is the oxide fluoride. So the oxidation number of this oxygen is +2, it's +2. The fifth rule, so in compounds, the sum of oxidation number in all constituent atoms is equal to 0. So if you're given any compound, like for instance, I've given you one example here, water. We have water here. So what is the oxidation number of that? We said if a compound has no charge, then the oxidation number is 0. How do we get that 0? By adding the oxidation number of the constituent atoms that have formed that compound. For instance, we've said hydrogen in all compounds has an oxidation of +1, because this is not the exception, where the exception for hydrogen is the metal hydrides. So here hydrogen has an oxidation number of +1. But how many hydrogen do we have here? We have 2 of them. So we're going to have 2 into bracket +1. Then oxygen. In this case, oxygen is going to have an oxidation number of -2. So when you add this, then it's giving you the 0. So compounds which have no charge, they're not radicals, then the oxidation number of that compound, you can get it by adding the oxidation number of the constituent elements. Finally, our last rule. So in ions containing more than one element, the overall charge is equal to sum of the oxidation number of the constituent elements. The overall charge is equal to the sum of the oxidation number of the constituent elements. So I'm going to give you an example. Like for instance, we can have any radical. We can have like the OH. That's the OH ion. So even before So we can be able to conclude that the oxidation number of this compound therefore should be -1 because it has a charge of minus there. So how do we get that -1? So oxygen, what is the oxidation number of oxygen in this compound? It is not in the exemption. It is not, that's not a peroxide, neither is it the oxide fluoride. So the oxidation number of oxygen in this case is -2. We only have one oxygen. Then plus hydrogen. Hydrogen has an oxidation of +1. So +1. So when you work out that, it will give you -1. So the oxidation number of an ion is equivalent to adding the sum of the oxidation number of the constituent elements. So next, we're going to do a few examples of calculating the oxidation number using our 6 rules. Thank you.